Tonight on the Astronomy Show, we focus on the moon. UBC's President Dr. David Strangway gives us an insight into his involvement in the Apollo moon missions. And there's a new comet in the sky, and David Dodge will tell us about it, Comet Hyakutake, and how to locate it. Eric Dunn and Lee Johnson will show us how to observe the moon. And of course, David Dodge with Astro News. All this and more on the Astronomy Show.
Good evening. Welcome to the Astronomy Show for the month of March. Throughout history, man has had a fascination with our close satellite, the moon. But even up to the 17th century, the discovery of the telescope, man still believed that the moon was inhabited. In fact, Sir William Herschel believed that the moon actually habitation was very similar to that of the Earth's. A German astronomer of this period claimed through his powerful telescope that he actually saw cities and buildings, etc. I would have liked to look through his scope. Even today, a lot of myths still prevail about the moon. As an example, farmers will tend to plant their crops on the basis of the phases of the moon. And different cultures believe in marrying on a full moon, hoping for a more successful and happy marriage. And then we have some people, of course, claim that they start growing hair on their hands, claws start developing, hair on their face, probably descendants of the late Lon Chaney Jr., and claim to be werewolves. Of course, when you think about it, the word lunatic actually comes from lunar. And of course, we have the loony. Oops, it broke. Well, other myths about the moon still prevail. There's the blue moon. And coincidences of coincidences, we're actually going to have a blue moon. This occurs when there are two full moons in 1 month. So the month of June will have a blue moon. And at this particular time, we're going to have, on behalf of the Royal Astronomical Society, a Blue Moon in June moon party. This will take place on June 30th, and there'll be more details about the location and time, etc. Now, we're promising that you will see a blue moon, as some of the club members actually even have filters that they can use to create a blue moon. A blue moon actually does exist on two occasions. Back in 1883, when Krakatoa erupted, and there was so much pollution in the atmosphere, the moon did turn blue. Same thing happened in 1950, when over the Canadian forests, there were so many forest fires going on, again we had a blue moon. Well, exactly 46 years later on that date in 1950, September 26th of this year, we're going to have another spectacular lunar event, and that's going to be a total lunar eclipse. And once again, the Royal Astronomical Society of Canada, Vancouver Centre chapter, will be setting up our telescopes and having a moon total lunar eclipse party. You'll be more than welcome to attend that event too, and again we will have details, time, and location. Well, I hope you're going to enjoy our show tonight, as we're going to look at the more lunatic fringe element of our wonderful moon. Thank you.
The moon, the Earth's only natural satellite. When you look at the moon in a nice clear evening, you tend to think wonderful thoughts about, well, love perhaps. Some people look at the moon and say, now is the time to plant your peas, your carrots, vegetables in general. The moon has been used by various cultures around the world for a whole bunch of different things. It's the first form of calendar. The word month comes from the word moon. It was the first way of marking long periods of time. From one full moon to the next full moon was a month. That doesn't really work in our current calendar the way we've got it set up nowadays, but it was a good beginning. Some cultures still use the moon as the main form of calendar. The moon is the Earth's only natural satellite in space. It's about 4,000 kilometers in diameter. In other words, if we were to place the moon over Canada, Vancouver would be here, and Montreal would be around here somewhere. Now, where did the moon come from? Well, nobody was there to make a movie of the moon, so we'd only be speculating. We used to think that the moon formed at the same time that the Earth formed, out of the same solar material, the same cloud of stuff that the sun formed. But we now think that that's not the case. We now think that maybe the moon formed separately, shortly after the Earth formed. The Earth is about 4.5 billion years old. The moon may be only about 3 billion years old. And what we think happened was that a wandering large body like an asteroid came too close to the Earth one time and smashed into the Earth and chipped off a bit of Earth stuff, and the asteroid stuff all merged and melted and reformed again into a glob that stayed in orbit around the Earth. We've discovered that because when we went to the moon, we found materials of different quantities and qualities, and some materials are absent that we have on the moon that we don't have on the Earth, and the other way around. Well, that's how the moon formed, but how does it get to be the way it is right now? When we look at the moon through a telescope, we can see lots and lots of craters, holes in the moon, like Copernicus and Tycho down here. Well, where do they come from? Well, when the solar system formed, large bodies formed first, and whatever was left over was just scattered around like crumbs. Well, some of those crumbs, let's say this crumb right here, about the size of Vancouver, for example, was wandering around, and there's our moon. That's how craters formed. Something like that probably got rid of the dinosaurs some 65 million years ago. So the next time you're out looking at the moon, think about where it came from, think about how we've used it as a calendar, and maybe, if you look at the moon carefully, you might see the man in the moon, or the lady in the moon, or the bunny rabbit in the moon. Those features are made up by looking at the highlands, these white areas, and the dark areas. You can almost see a bunny rabbit over here, with its tail over here, or the lady in the moon, and the man in the moon, using the darker areas. So the moon's a great thing to learn about astronomy. Follow the moon, it passes by all the planets. Look at the moon over time, understand how the phases happen, and it's a great stepping off place for the rest of astronomy.
I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
To the astronomer, the atmosphere is often an enemy. It does tend to ruin the view of whatever you're trying to look at, so you want to look through as little of it as possible. One of the great sights in astronomy is the first quarter moon, and it's at this time of year, in springtime, that the first quarter moon is highest in the sky. So it's a great time for moon watching. And Lee Johnson has joined me here, and we'd like to talk a little bit about the fine art of watching the moon. Lee, this can be approached on many different levels.
Well, it certainly can, Eric. We can do naked eye viewing of the moon. First of all, to follow the moon in its phases against the background sky as it rises later each evening. But to maximize one's enjoyment of the moon, one really needs to magnify it. And the best way to look at the moon with magnification is through binoculars or a telescope.
Why would you use binoculars? And you'd think immediately that, well, you want to be serious about moon watching. Wouldn't you use a telescope?
Well, binoculars are a great way to begin your observation of the moon. If you have a pair of binoculars and a book from a local astronomy store or from a bookstore that gives a map of the moon, you will be able to identify the seas and the mountain areas of the moon with a pair of binoculars and learn your way around the moon's topography. And once you've done that, you can proceed to the telescope, which can give you high-powered views of the moon with high magnification.
That's perhaps the most exciting way to look at the moon is through a telescope. Through reasonable magnification, the kind that you can get with amateur telescopes, you can get much the same view that you would have through the window of a spacecraft from about 1,000 kilometers above the lunar surface. And it's a very spectacular view indeed. Now there's, of course, many different types of telescopes. Some are more suited to moon watching than others. We've got a couple of sample instruments here with us today, and they have their pros and cons as lunar instruments. This one is a very nice moon watching telescope. It's called a Quantum 6. It's technically a Maxitov telescope, a compound telescope. It uses both mirrors and lenses. And it has the advantages of being equatorially mounted. It has a clock drive in there. It will track the moon as it moves across the sky. And it's a very solid mount as well. This thing will not vibrate a lot, and that's extremely important when you want to use high power on the moon. And it's such a gorgeous looking object, you will want to use high power. You'll want to get in there as close as you can. But this is only a 6-inch telescope, or 15-centimeter telescope. This is considered fairly small stuff by current standards in astronomy. A lot of amateur astronomers out there will have much larger instruments. And oddly enough, that can be a bit of a problem when it comes to watching the moon.
Well, it certainly can, Eric. I have a telescope here which has a 10-inch mirror, or 25 centimeters, And that means that that telescope gathers 1,300 times as much light as the dark adapted naked eye. And a view of a bright object like the moon can actually blind you through a telescope with this big a mirror. So one way of cutting down the glare from the moon on a telescope of this size is to use something called an off-axis mask, which reduces the aperture and the amount of light gathering that the telescope is delivering to the eye. Another way is to use filters in your eyepiece. A filter can cut down the glare of the moon as well. But these are two main ways of cutting down that glare so that you can see detail on the moon without ending up being almost blinded by the sight of the moon through a large aperture telescope.
Of course, a filter is just basically like putting sunglasses on your telescope, or moon glasses, I suppose. But of course, it is a piece of optical glass, and they are expensive, whereas an off-axis stop like this is just a piece of cardboard with a hole in it, probably the lowest tech astronomical gear you will own, and it can make an astonishing difference to your view of the moon.
That is certainly true.
It may seem ironic that it's possible to have such a thing as too large a telescope, but for moon watching that can be the case. And the problem is not only the glare, but also the turbulence of the atmosphere. And when you look through a narrower column of air, you pick up less turbulence, and that view will not appear to be swimming around and changing and getting all fuzzy on you. You'll have much more satisfying views very often if you take a telescope of this size range and stop it down.
And once you've stopped it down to cut down the glare, you look along the terminator, the point between the light and the dark shadows on the moon, to get your best views with the maximum contrast. And looking along the terminator, which changes during the course of each night, you can get an excellent high-power, high-magnification view of details on the moon and identify them with the help of an atlas.
So the moon is up there this month. It's high in the sky. It's particularly beautiful to look at. Go and check it out.
The whole of the astronomical community is in a big tizzy these days over comets. Recently, a comet Hale-Bopp was discovered, and it's going to do great things next year. But in January of this year, Hyakutake of Japan discovered a comet, his second comet in 6 weeks, by the way. This comet is going to do wonderful things in our evening sky between the latter part of March and the first part of April. It's going to be crossing our evening skies, crossing near the Big Dipper, the Little Dipper, and Cassiopeia. Watch for the comet. Now, what you're going to see is a large fuzzy ball of light, and this is the coma, the outer gases of the comet. Remember, a comet is a bunch of frozen gases that gets warmed by the sun. And as the comet gets closer to the sun, these gases are driven off, and this becomes the tail. Now, what we're going to see as far as tail is concerned is open to anybody's guess. But what we're predicting right now is it's going to be a large glow of light. Now, let's just identify where to look in the evening sky for Comet Hyakutake. First off, look towards north, and you'll see the Big Dipper. And then down there is the Little Dipper, and a bit further on is Cassiopeia. Those are the main players in our evening sky. Now watch what happens between March the 22nd and April the 1st as Comet Hyakutake crosses those constellations. Comet Hyakutake should become visible around March the 21st as it passes by that really bright star Arcturus in the northeastern part of the sky. It moves very quickly over the next few days past and below the Big Dipper. On the evening of March the 26th, it passes right beside Polaris, the North Star. Then its motion starts to slow down, and it gets somewhat fainter as it goes away from the Earth. And watch as it passes by Cassiopeia later this month. Towards the beginning of April, the moon will become a part of the evening sky and will block out the faint light of the comet. The comet recedes from the Earth but starts approaching the sun, and the comet will start to brighten up. And the comet will be very spectacular were it not for the evening twilight we'll have in April. So we've got a really bright comet in the sky. It's passing some very well-known groups of stars. All we need now is clear weather.
10, retro, engines go, guide 5, roll, go, 3, go, 2, econ, launch commit, go.
It was very exciting, I guess, for a lot of reasons. One is, of course, everybody was working for a very common goal. There was a common set of objectives. Each individual, no matter how talented they were, was given a particular task, and that task had to be done and had to be done right, because if during the mission something went wrong with the lunar rover, or something went wrong with whatever it was, the rake or the sample bags or whatever, somebody had to be there who knew how to answer that question in real time. And so people became very expert at those pieces that they were expected to be expert on, and were on call and on duty for whenever needed. That gave a real sense of excitement, that you were part of this incredible endeavor, and that if you let the piece down, or your piece down, that you might let the whole team down, in effect. The other thing that was, of course, very exciting was, in addition to the large central control center that was the one where the actual flight controllers operated out of, there were several other control rooms that were situated around it, which fed into the central control room. One of those, for example, was where the medical doctors were, and they would be monitoring all the time the conditions of the astronauts from the sensors that they had on them. There was another one that was to do with orbital dynamics, always keeping up to date with keeping the calculations going as to if something went wrong, you know, how do you immediately get back to Earth? If you get back to the Earth, how do you get into Earth orbit without overshooting or undershooting, and all those kinds of things. There was also a science back room, and that was the room where I was engaged, was in the science back room, and there we had the team of people who were engaged in making the priority decisions, if you like, with respect to what was to be done, how they laid out the experiments, and all the rest of it. And again, in that room, we had one person who was the spokesman, who fed into one of the consoles in the main control room. My particular interest in the lunar samples had to do with two major areas. One was the measurement of the magnetic properties of lunar materials, and the other was the measurement of the electrical properties of lunar materials. Both of these, I think, are fairly important dimensions, but there's lots of other important dimensions to sample studies. In terms of magnetism, for example, you can use magnetism to determine the composition of the metallic materials that were within it, and the nature of the iron and the iron nickel that was in the lunar materials. But the other thing you can do with it is to reconstruct ancient magnetic fields, because just as the tape recorder that you're taping this on has tiny little magnetic particles that are preserving this on the tape, so there are tiny little magnetic particles in most pieces of rock that preserve and memorize and keep the memory of that early magnetic field. So we were very interested in reconstructing the magnetic field at the time when those lunar samples were formed. From the first point of view, we found that the material itself, in terms of composition, was not an iron oxide as we would have on Earth. It was a very reduced form of iron, and it was pure metallic iron, sometimes mixed with little bits of nickel and cobalt and other alloying materials. But basically it was pure metallic iron. There would be very few places on Earth that you could find pure metallic iron, for the simple reason that when it forms on the Earth in the presence of water and atmospheres and oxygen and so on, they become oxidized. So you get lots of iron oxides, which is what forms our big iron ore deposits, and then we spend an enormous amount of money extracting it and making it back into iron. Well, the lunar surface had a fair amount of pure metallic iron on it. The second thing we found in terms of the magnetic fields and the preservation of them is that there were very clear indications that there were very weak but indeed significant magnetic fields present in the period of those lunar materials. Now, the lunar moon itself was formed probably 4.5 to 4.6 billion years ago, and the highlands are pretty well impacted and melted and remelted and so on, forming these breccias as they brought them back. So most of the lunar surface, the light-colored parts of the lunar surface, turned out to be about 4 billion years in age. The dark areas of the moon, or the basalts, typically range from about 3.2 or 3 billion years up to 4 billion years in age. So what we found was whether we had samples that were 3.3 billion years in age or as old as 4 billion years in age, they still had a significant memory of some magnetic field that we believe must have existed at that time.
If you got word that they were going to go back, that somebody was going to go back to the moon, what would you want them to look for? Where would you want them to go?
Well, interestingly enough, one of the things I'd want them to do is to go back to one of the old sites. Because what I'd like them to do is to bring back some of the pieces that were left, that were artifacts that were left up there, because 25 years ago, and thinking about the exposure to the high vacuum conditions, thinking about the exposures to the solar wind flares and all of the galactic cosmic rays and so on, would, I think, give us a very interesting record of what actually is going on in that atmosphere. So I'd actually like them to go back and bring back some carefully preserved artifacts from some of those materials. Of course, there's lots of things I'd like to learn about the moon itself too, so I mean there are lots of other places to go. I'd like them to go to way out of the equatorial zone, which they were restricted to during the Apollo, and get up into some of the very high latitudes, possibly up into the polar regions of the moon. Reason that polar regions would be interesting is, first of all, we don't have any very good pictures of the polar regions, although there's some now. But it would be very interesting to see whether there's areas, for example, that are in permanent shadow and things like that.
Well, welcome to Astro News on the Astronomy Show. And as usual, we'll start off with the phases of the moon. The full moon is on the 5th of this month. Last quarter is on the 12th. New moon is on the 19th, and first quarter is on the 26th. This month's full moon is called the Sap, Crow, or Lenten moon. Spring officially arrives in the Vancouver area at 3 minutes past midnight on the morning of the 20th of March. On this day, at this time, the sun, in its apparent path around the Earth, crosses the equator on its northbound leg. From March the 20th through to September 22nd, the days will be much longer than the nights. Another sure sign of spring is the changing of the clocks. Although this doesn't happen until 2 o'clock in the morning of April the 7th, I thought this would be a good opportunity to give you a bit of advance warning. Some other things to look for in the sky this month. Well, first off, let's stop right at Venus. Have you been watching Venus, that really bright planet over in the western part of the sky? Venus is a planet about the same size as the Earth, 12,000 kilometers in diameter, and it's totally covered in clouds. Clouds are made of sulfuric acid. Venus is very close to us right now. So the light it receives from the sun is bounced back out into space by the clouds, and because Venus is close to us, astronomically speaking, its light is not reduced. Do you know that Venus is so bright you can actually see it during the daytime, if you know where to look? Well, on the morning of the 23rd, look for the moon in the daytime sky, and 1 fist width south of the moon, you should see Venus, a sparkling, brilliant point of light in the daytime sky. It's always a surprise when you can find Venus during the daylight hours. Spring comes in like a lion and goes out like a lamb is a chestnut you often hear at this time of year. But do you realize there might be an astronomical connection to this phrase? Halfway up the southern sky right now is the constellation of Leo the Lion. And over in the west, where Venus is right now, is the constellation of Aries the Ram. So at this time of year, Aries the Ram is setting and Leo the Lion is rising. So maybe that's what we're talking about. Leo the Lion, Aries the Ram. In like a lion, out like a lamb. Jupiter's part of our sky these days again. Over the past few months, Jupiter and its motion around the sun, and more importantly, our motion around the sun, has caused Jupiter to get away from the glow, the twilight glow of the sun. You can see it in the early morning hours. A pair of steadily held binoculars to aim towards Jupiter might show upwards of 4 of its tiny moons. And tiny is only relative. They're at the same size or somewhat larger than our own moon. On the morning of the 3rd, try looking for Jupiter in the morning sky with a pair of binoculars, and you should see 4 of its moons, 2 on one side of Jupiter and 2 on the other. Now, while you're looking at Jupiter with your binoculars, remember you're also looking in the same area that Comet Hale-Bopp is currently residing. Now, you won't be able to see it with a pair of binoculars right now. You will in a few months, and the Astronomy Show will keep you apprised of what's happening with that comet. In the meantime, don't forget we have Comet Hyakutake is going to put on a fantastic show in our evening skies this month, towards the latter part of this month, after spring break, in the first part of April. And all we need for that, of course, are those clear skies. Well, that's it for the Astronomy Show. We'll see you next month.
The preceding program was produced through the facilities of Rogers Community 4, Vancouver. We want to hear from you and invite you to leave your comments and suggestions on our 24-hour response line message machine. Please call 731-5812.